on the negative end and attracts them to the metal bump on the positive end. Electrons will start to move from minus to plus if the right kind of material is connected to the battery. Materials that allow electricity to travel through them are called conductors. Most metals are good conductors of electricity. Copper is the most common metal used in wires. In this animation, a conductor is connected to each terminal of a battery. Electrons start to move, traveling from the negative terminal towards the positive terminal. This is electricity. The electrons actually move from atom to atom as they travel through the conductor. This is a safety warning. Never connect a short metal wire between the terminals of a battery. This is a short circuit. The wire will get hot, you might burn yourself, and the battery will quickly lose its energy. Have you noticed the letter V on the side of a battery? This represents volts. Volts, or voltage, is a measure of the force moving the electrons. A AA battery is usually 1.5 volts. This is a low voltage, and that is why it is safe to handle a AA battery. Higher voltages are dangerous. Never experiment with anything that plugs into a wall outlet. Wall outlet voltages range from 120 volts to 240 volts. Extremely dangerous. Here is an example of a low voltage battery being used to create some light. Connecting a light bulb to this battery, we have created a circuit, a path for electrons to travel on. Our light bulb does two things. It introduces some resistance into the circuit, reducing the flow of electrons so that the copper wires won't get hot, and it converts electrical energy into light energy. Our circuit also demonstrates a switch, a device for turning the electricity off and on. The switch does this by creating an opening in the circuit. This is an actual circuit similar to the one in the animation. The wires I am using have metal alligator clips connected to their ends, making it easy to connect. The metal in these wires is covered in plastic. Plastic is an electrical insulator. The current from our low voltage battery will not flow through the plastic, but easily travels in the copper wire under the plastic. Connecting and disconnecting the wire creates a simple switch, turning the light off and on. A wall switch does the same thing. The plastic lever and cover plate protect you from the high voltage used in this circuit.